All right, the first unit of Unit 3 here is we're going to be looking at solving systems of equations. So we're going to look at the three different ways you can do that, that being graphing, substitution, and eliminations for your learning target. In this first problem on your note sheet, it says the initial cost for Travis and his band to record their first CD was $1,500. Each CD will cost $4 to produce. If they sell their CDs for $10 each, how many must they sell before they make a profit? Okay, so using this information, what we want to do here is first find an equation for the cost of the CDs. Okay, so cost, let's use Y for the cost. And what we know is the cost is going to be $4 to produce, plus it says also that to record their first CD, it's going to be a one-time cost of $1,500. So we have $4 per CD, so we're going to use a variable. Let's use X for the number of CDs, plus the one-time cost of $1,500. We do not need to put an X next to $1,500 because it's not that amount for each CD, it's just a one-time cost. All right, next. What they want to do is us to find is what's an equation for the income of the CDs. So looking at the income, it says income is going to be $10 for each CD. That's how much they bring in. So again, our money equals $10 per CD. All right, the last one here. They have a graph on here, and what they want us to do for the graph is to find out how much that, or what is this point where there's a little dot here on the graph. So what they did is they graphed out both of these equations. Both are y equals 10x and also our y equals 4x plus 1500, and they cross at this point. That point we're going to refer to as the solution, and the reason that we call it this is that is what's referred to as kind of the break even point. That is where these two equations are equal to each other. It's where the cost, in this case, equals the income. So if they were to produce 250, that looks like the CDs. So if they produce 250 CDs, the cost and the income are both going to be $2,500, meaning the cost equals the income. Any CDs they make over 200, or over 250, they then should start making profit. Okay, so systems of equations, like you saw in the last problem, we had two equations, two lines. We want to find out when they're the same. There's three ways to solve these types of systems of equations. One is, like you just saw, would be to use some graphing. Graph it out. So graphing is one way. Another way is a method called substitution that we'll look at. And a third way that you're probably a little bit familiar with here is called elimination. Okay, and we'll look at which way is best depending on the problem. When you solve systems of equations, there's three types of solutions you can get. One solution is possible, and that's like we got in the last problem. When we solved this one problem, these two lines crossed once, we got one solution. So that's when you have intersecting lines, when the two lines are intersecting. You can also get a solution, or what's called a no solution problem. And that's where you would have two lines that would never cross. If you end up having two lines that never cross, that would look something like this. and back in geometry, you refer to those as parallel lines, then we say that there's no solutions. Parallel lines. Okay. We talked about already intersecting lines. The one other thing that could happen would be that you graph your two lines and they actually end up being the same line. Well, in that case, your lines are they're touching at every spot. There's infinitely many solutions. And we'd say there's infinite solutions because every point is basically a solution. Every point's the same. So you can also have infinite solutions. And that's where the lines are the same. That situation doesn't happen too often. There's not many times where your two things end up being exactly the same. Okay, so let's try one out. We're going to try to solve this system of equations by using the graphing method. So to use the graphing method, we want to graph out both equations listed in this system here and see where they intersect, or possibly see where they don't intersect, or see if they're the same. We can tell probably from this that these two are not going to be the same line because they're not the same equation. And if we tried simplifying them, they also would not be the same equation. So it's probably either that these two lines cross at one point or that they are parallel. So how do we graph these out? These lines, we could do one of two methods. We can get them in slope-intercept form, which you guys are familiar with, or we can use the cover-up method. For this first one, let's try getting it in slope-intercept form. So we have the equation 2x plus y equals 5. Okay, so to get it in slope-intercept form, we want it as a y equals equation. So let's subtract this 2x to the other side, making that cancel out. So now we're left with y equals, that's what we want for slope-intercept form, 2x plus 5 is now on the right side. Well, that's the slope-intercept form. Remember that this is your slope, this being your y-intercept. So now on our graph, if we start at the y-intercept of 5, which would be right there, and then we use the slope of -2, meaning -2 over 1, since it's not a fraction, we can always make it into a fraction by putting it over 1. We want to go down 2, right 1, down 2, right 1, down 2, right 1. And if we just continue that trend, now we have our line. So that is the top line. Okay, we could do the same thing for the bottom line. Let's try a different method for this one. Let's use cover-up method. So remember, cover-up method is where you cover up one variable and see what the other is, basically substituting 0 in. So let's cover up the y. If we cover up the y, here our equation becomes x equals 1. So on the x-axis, let's put a dot at 1. If we cover up the other variable, meaning we're substituting 0 in for x, now we have the equation -y equals 1 left. Well, solving that by multiplying or dividing by a -1 means that y is going to be -1. So if we put a dot at -1 on the y-axis and connect those two, that's the equation for the other line. So just continue that trend, and that's the other one. So that is the second equation. So now that we have both equations, what we want to try to figure out is the solution. And seeing that these aren't parallel, there should be one solution. And our one solution is that point where they intersect. So the solution on this one, and you should label it on the graph when you have one solution, would be that these two cross at the point 2, 1. 2, 1 is the solution. That's the point where these cross. Meaning if you put 2 and 1 into both of these equations, that makes them both true. 2 minus 1 does equal 1 for the second equation. If you put 2 and 1 in here, you got 2 times 2 plus 1 does in fact equal 5. 4 plus 1 is 5. Okay, let's try another one out here. We want to graph these two out. If we look at the first one, that might be one that looks like it could be good for cover-up method. However, if we do cover-up method here, we'd have to divide 7 by 5, and that doesn't look like it's going to come out very nice. So maybe cover-up method's not the best. Let's try getting that in slope-intercept form. So if we're going to get this top equation here in slope-intercept, again, we want to solve for y. So first, let's move the 5x over to the other side by subtracting it. So now it's going to be negative 5x when we subtract that to the other side. Now we still don't have y by itself quite yet. We need to divide by 4. So if we divide by 4 there, that means everything on this other side also needs to get divided by 4. So now our equation becomes, and we're going to leave this as a fraction because 4 doesn't go into 5. So let's leave it as a fraction, negative 5/4 x plus, and 4 also does not go into 7. Let's leave that as 7/4. Okay, so we'll graph that one out. 7/4, if you divide that out, is the same as 1.75. So we got to do a little bit of estimation here. 1.75 might be right about there. And then we got to go down 5. 1, 2, 3, 4, 5, and over 4. So another point's right about there. If we connect these, that's the top line. Okay, let's graph the second line. This one already is in slope-intercept form. There's no need to solve anything here. Start at 4. 1, 2, 3, 4 is right there, and our slope is negative 5/4. Down 5 over 4. Okay, connect those. And hopefully you notice something about these two slopes. In both cases, our slope here was negative 5/4. Anytime you have the same slope, that means these lines are going to end up being parallel. And if we have parallel lines, that means they're never going to intersect. So this one we would say has no solution. These two lines will never be the same. There is no coordinate, xy coordinate, that makes both of these equations true. So this would be a no solution problem. Okay, so if you go to the back of your worksheet, we are going to next look at solving the system of equations by using substitution. Substitution is a method where we are going to substitute one equation in for another. When you're doing the substitution method, some things to look for is to get one of the variables by itself in one of the equations. Luckily for us, we kind of have that going on right here. If you look at the top equation, you have y by itself on one side of the equation. That's what this first step means. So this is going to be a good one to do substitution. We're going to substitute what y equals, which is half x minus 18, in for the other variable in the other equation. So step 2, substitute this new equation into the other equation in place of that variable. So we're going to take this, and where we see y in the second equation, because this is what y equals, we're going to plug that expression in for y. So that's our next thing. Once we do that, we are now going to solve for this variable. So let's make the substitution here. If we substitute that in, our equation becomes x plus, there's still a 2 there. The y is going to become something new. Still equals 18. What we're going to put in place here is what we're substituting, 1/2 x minus 18. So let's solve for that variable. And this one, it looks like we are going to have to proceed by doing some distributing here. So 2 times 1/2, half of 2 is 1, so that's just going to be 1x. And 2 times negative 18 is negative 36. Let's combine these like terms here. This is also a 1x, so 1x plus 1x is 2x minus 36 equals 18. If we add 36 to both sides, we are going to get 54. And then divide by 2, it looks like x is 27. Now, we're not quite done. We did do a lot of good work there, and we're close, but there's still one step left. We now need to plug this new variable into either one of the two remaining equations and solve for the remaining variable, meaning we got to find y still. So which one, looking at these two equations, is a better one to plug it back in for? It's kind of up to you, but usually, especially if you got one of these equations where they give you a variable equals something else, is going to be the best one. So we know that we can take this equation, take the 27 we just found, and put it in for x. So it becomes half of 27 minus 18. Half of 27 is going to be 13.5. And if we minus 18 from that, we get negative 4.5. Now we have y. Okay, so that's the solution. And you can circle both like that, or you can list it, because really it's a part of a graph listed as an ordered pair. 27, negative 4.5 would be another way you could list your answer. You could also run into these in word problems. Let's read through this one. It says, Matthew stopped for gasoline twice on a long car trip. The price of gasoline at the first station where he stopped was $2.56 per gallon. At the second station, the price was $2.65 per gallon. Matthew bought a total of 36.1 gallons of gasoline and spent $94. How many gallons of gasoline did Matthew buy at the first station? We need to come up with some equations from this information. So let's start with this first sentence where it says, at the first station he stopped, it was $2.56 per gallon. That by itself is going to be tough to do because we don't have similar things. So if you can't go by sentences, then look for similar information. There's a lot of money in this problem. We got money here, we got money here, and we have money here. So let's put all the stuff with money together then if you can't go sentence by sentence. So $2.56, that's from the first station. So let's use X for the first station. Plus you got gas at the second station, it was $2.65 at the second station. Let's use Y for that. And then the total that Matthew spent was $94. So if we add up the money from each of these gallons of gas at each station, this should equal $94. So there's one equation with the information. All right, but we need another one because we got two variables. We can't solve two variables unless we have two equations. The other thing we know is that he bought a total of 36.1 gallons of gasoline. Again, that's a total. So just like 94 was a total, let's put 36.1 as a total. But what do we put this equal to? Do we again want to put this in there? Nope. We don't want to do that because we've already dealt with the money side of it. X and Y are the number of gallons from each station. Station X or station 1 and station 2. So in this case, all we got to do is put X plus Y, because X and Y are the number of gallons. The number of gallons times the dollar amount here is going to give you the price. So we're dealing with number of gallons. So these become our two equations. Now we want to solve this. Okay, to solve this, we can use that method we just did by solving for one of the variables. So again, let's pick one to do. It looks like the second equation is probably a little bit easier to do. Let's minus an x from both sides and get the equation y equals 36.1 minus x. Now we can do some substitution and substitute this information in for the y variable here because that's what y equals. So doing that, we get the equation $2.56 times x plus $2.65 times 36.1 minus x gallons equals $94. So solving this equation now, we should be able to find x, because now x is our only variable in the problem. All right, we're going to have to, again, start by distributing. So if we take $2.65 times 36.1 gallons, let's see what we get. Looks like it comes out to be 95.665. and we want to use all that information right now, don't round off, minus, if we take 265 times negative x, that's just going to be minus 265x. Okay, let's put these like terms together. Both of these have a variable. Okay, so if we combine those together, we're going to get negative 0.09x. Now we got to get our constant terms together. Constant means the terms without variables. They're on opposite sides, so here we're going to need to subtract this over to the other side. And if we subtract 95.665 from 94, that's going to be a negative 1.665. And our last step here now looks like we need to divide. Divide by the number in front of the variable. So if we divide by this negative number, we should have our answer because that's going to cancel out. So the number of gallons at the first station, which they were asking us to find here, would be make sure you get negatives in there when you're typing it in. Negative divided by a negative should be positive. So it looks like 18.5 gallons is the answer. Now you got to be careful on these types of problems. If you would get this, say, on an ACT test, you would want to make sure that you are finding the one. They wanted us to find first station. The question asked, well, how many at the first station? And we were using X as the first station here. So the answer is 18.5. There would be no need in this problem to find Y because that's the second station. Now, had you solved this for Y first, then you would need to plug it back in and find X because that is the one they asked us to find. Okay. The last step we're going to look at, we looked at graphic substitution, is called elimination. Before you do elimination method, make sure both equations are in standard form, meaning ax plus by equals c. And we do have both equations in that standard form. The next is to pick a variable that you are going to eliminate from the system. So look at the two variables and try to figure out which one's going to be the easiest to get the same. In problem 4a here, it is quite obvious that y is going to be the best one because you got both 2 and negative 2 there. So that would be the best one to eliminate. Next step, what do you need to multiply by on the bottom equation and top equation so that the two equations are the same? This step we'll come back to. We won't need it in this problem because we already have the right number there. So we can kind of skip this one for now. Okay, step 3. Now multiply both equations. And again, we aren't doing the multiply one now, so we'll come back to that. Step 4, add the two equations together. Here's what we want to do now. We want to add these together. So think of it as an adding problem, and if we were to add these up, what would we get? Well, if we add 4x and 2x, that's going to give us 6x. If we add 2y and negative 2y, those eliminate. Those equals 0. You don't need to necessarily put a plus 0 there because 0 is gone. We have an equals on both of these, so bring down the equals. 15 plus 9 is going to be 24. Now we got an equation with just one variable. We can solve this by dividing by 6. And it looks like x equals 4. So once you get both of those done, now you got it. So we have those steps in the problem done. The next thing we need to do is, like we did with substitution, take that value, substitute back in, and find the other one. So we still need to figure out what y is. So here you can pick top one, bottom one, it doesn't matter. Whichever one you think looks easier, plug that back in. I'm going to just do the top one here. 4x plus 2y equals 15. Take 4, make sure you substitute 4x because that's what x equals, and solve for y. So 4 times 4 is 16. We want to subtract 16 from both sides, that'd be negative 1, divide by 2. And it looks like y here is going to equal negative 0.5 or negative 1/2. So that's y, that's x. And again, you could list it if you want. You could list it as a ordered pair as 4, negative 0.05. Would also be an acceptable way to do it. Okay, let's try another one. This one. If we were to add these two up like we did the last one, we're going to run into trouble here because nothing would eliminate here if we just added these together. So this is where we got to go back and use those multiplying steps. So we need to multiply the top and bottom by something to make these the same. So if you look at, say, the x's, what's a number that both 2 and 3 multiply into? 6. So let's multiply the top by 3 and the bottom by 2. That would make them both 6. However, we also want it so that one of them is negative and one is positive. Notice in this last one, when we add these up, we want them to equal 0. We want 1 plus and 1 minus. So in front of one of these, let's throw a negative sign. And it doesn't matter which one. Let's pick the bottom one. So if we do this multiplication now, we should end up with something canceling out. So in the top one, we'd get 6x. Multiply 3 and negative 4, you're going to get negative 12y. Make sure you multiply the constant term on the other side of the equals also by 3, and you would get negative 78. On the bottom, we're going to multiply everything there by negative 2. So it'd be negative 6x. Negative 2 times, this is like a 1 here. Negative times the negative is going to be positive 2y. And also, again, make sure you multiply the constant term. 2 negatives is going to be positive. 2 times 24 is 48. Now we are going to add these together. And our two x terms should equal 0 here, so they eliminate or cancel out. If we add our y's, we get negative 10y. If we add our constant terms, we get negative 30. Now divide by negative 10. And we find out that y equals 3. So that's why we got to find x, so plug it back in and see what x equals. Let's just pick the top one again. If we plug it back in here, we got 2x minus 4y we found out to be 3 equals negative 26. If we do some multiplying there, that's negative 12. If we add 12 to the other side, we got now 2x equals negative 14. And that ends up giving us negative 7 for x. So our answer would be negative 7, comma 3. That's the location, if we graph these out, where these two lines would intersect. We could have also done the same problem using elimination a little bit different had we wanted. Maybe some of you thought of this. Another way you could have made these the same would be to multiply just the bottom one by negative 4. That would have eliminated the y's. That would have been another option for you. All right, last problem. This is using now a system of equations to do another word problem. In order to practice at home, Sammy purchases a basketball and a volleyball that costs a total of $67, not including tax. If the price of the basketball is more than twice the cost of the volleyball, find the price of each using a system of equations. All right, so let's start out here. It says Sammy purchased a basketball and a volleyball that totaled 67. Let's use B for basketball, V for volleyball. It says if we buy both, the cost is $67. So that's one equation. Both together equals 67. The second one here, now we're kind of going by sentence. The price of the basketball is more than twice the cost of the volleyball. So the basketball is, remember, is usually means equals. Basketball is more than means plus, twice the cost of the volleyball. Twice, 2 times V. Now you want to solve that. Okay, see if you can pause this and solve that one out on your own and then check to see if you got it right. All right, let's see how you did. Personally, I would pick substitution on this one because we got a B equals, so we can substitute that in for B and get a new equation with only V in it. So it'd be 4 plus 2V is what we're substituting, plus this other V equals 67. Combine like terms. Keep solving. And divide by 3, and it looks like the volleyball is $21. And then we also need to find the basketball. Well, knowing this right here, that B is equal to 4 plus 2 times the cost of the volleyball, the price of the basketball ends up being $46. So basketball is 46, volleyball is 21. All right, try your worksheet out and see if you can solve some of these on your